point in time to predict what's going to happen next is not all that difficult. Okay, the big advantage, if you like, or the complexity of it is that we have so many brain cells, 100 billion, that you would need an awful lot of devices looking at all of the brain cells and trying to predict what all of them are going to do to get a full context of what's going to happen next. But in terms of some smaller features, they're looking at particular parts of the brain and saying, well, this is what's going to happen next. Yes, I think it's not all that difficult at all, and artificial intelligence systems, that's exactly what we're doing. It happens in a medical world with deep brain stimulators, and we can use those for measurement, so it's a particular field, but nevertheless we can get results from that which, if applied in a more general way, you could predict exactly what somebody is going to do for the next 10, 15 seconds at a particular point in time, so that if I could put enough electrodes into your brain and have an AI system, I could then say, right, in the next 10 to 15 seconds, this is what you're going to do. And I would be right. I would be almost without any error, be completely right and know exactly what you're going to do, which is worrying from the point of view of your free will. You know, how much free will do you have?
Right,
if I could say this is what you're going to do and I'd know exactly what you were going to do.
Exactly.
Well, before I even said that, some AI system would have known I was going to say that 10, 15 seconds ago.
That's very interesting indeed. And, you know, one thing that you mentioned also, of course, is that still there's some need of kind of that interface, that there needs to be a connection here between the neurons then and another machine. But I know that there have been research in regards to something called RFID dust, and this is basically something that is on the nanoscale, and this is basically, if this were in the air and you breathe it in, this is something that potentially could become a part of your body almost instantaneously, and consequently actually signal out to the surrounding environment of you know, the positions or even the impulses of let's say the neural system. Have you heard about RFID dust?
Yeah, I've heard about it, but I have to say, before I make a fool of myself, technologically I'm not 100% sure of exactly how it operates, but
right.
The nanoscale is certainly more than is required. Our brain cells, neurons, are typically 2 micrometers in diameter up to about 20 micrometers, maybe even 30 micrometers on a good day, but 2 to 20 micrometers. Now, if you're looking nano, you're going down about 1,000th of that. So you're getting sub-cell, sub-neuron size pieces of information, which is probably a lot more than you actually need. So it wouldn't surprise me if as you're talking about, nano-sized particles that are used for transmitting signals out. Yeah, I mean, it all sounds very, very plausible for the future. Just what's practically available now, I'm not really sure. But even at the micro level, you can pick signals up, send them out, and so on. But it's not easy for that to be inhaled as dust or that form. You need to push electrodes into people in order to do that.
Right, exactly. Well, I mean, this has been a very kind of, you know, enlightening in many cases, and considering that you're involved in, you know, in the top research of many of these areas, it's definitely worrying, you know, to begin with, but then it's also many possibilities opening up here. But this is definitely something that needs to be, as regards what I feel at this point is that we need to become more aware of what the heck we're doing right now, because things might get out of hand if we don't watch ourselves. And I consider it to be important to kind of have this kind of discussion about these subjects. We can begin to realize and be aware of where we're going with all this technology, and that's why I think it's you know, very important to do programs like this. And it's great having you here, Kevin, to talk about this and kind of help us to enlighten us about what is going on in regards to this research. You know, so I want to thank you very much for being on the program with us here today.
Oh, thank you. Really enjoyed it, and yeah, hopefully I haven't worried people too much. I mean, it is a tremendously exciting field. There's lots and lots of opportunities, and I encourage anybody who feels excited by the field, get into it. There's plenty there to learn about, plenty to do.
Very interesting. I do want to mention at last time here also that the website is kevinwarwick.com. There you can find links, resources, and other articles about the research that Kevin is doing. There's links to how to get the book, I, Cyborg, as well. And if not, go over to Amazon.com and check that out. But with that, I want to thank everyone for tuning in. And again, Kevin, thank you very much for coming on. And we'll see what happens in the future. Eh?
Thank you. Really enjoyed it.